Hi everyone, welcome back. Just going to go through some basics on 2D vectors, looking at my Year 11 Specialist Maths here in Western Australia's class results in the recent test. There's some basics that some of them didn't understand, so hopefully this will help them and others. I've had two vectors, 2i and 3j, and I have another one, 3i plus j. You can write them in other forms, I'll go there in a moment. So if I just wanted to do a basic every day, get the vector A and minus 4 times the vector B. We can go into lots of details, but no need to. I can used to sometimes go into diagrams and try to help my students really understand. Most people are okay though. If we just say, well, vector A, I'm going to write it as 2, 3. Writing it in that form I find is quicker and easier to do calculations because you're not worrying about all the I's and J's all the time. Then I'm going to minus 4 lots of B, and B is 3, 1. So all we're looking at really in this case is we're just going 2 minus 4 3s are 12, and I'm seeing students make mistakes with the negatives. 2 minus 12 is minus 10, and then I've got 3 minus 4 ones. 4 ones are 4, so it's really just 3 take 4, which is minus 1. Just be careful of negatives. One of the rules in Western Australia is that if you've got the question written in an assessment in this form, you normally have to write the assessment in, or be safe to write the assessment in the same form. So I could write that as minus 10i minus j. I haven't checked if the final exams, if they take any notice of that, but just something to be wary of. Okay, this time when we're talking about these, looks like absolute value signs, we're talking about the magnitude of A, not about the vector A itself, but all we're saying is how long is vector A. Now if I drew up a little diagram, which is easy to do, I could draw a diagram with 2i plus 3j. So if I started here and I went across 2 and I went up 3, you can see there's my 2i plus 3j. And what I've formed is a right angle triangle where this side is 2 and that side is 3. And there's my right angle triangle, and I can use Pythagoras Theorem to get the length of this vector here. So all I'm doing is I'm getting the square root of 2 squared is 4 and 3 squared is 9. If anyone's having trouble with that, I often write it as 3 3s are 9 and 2 2s are 4. And we're getting the longer side, so we're going to go to 9 plus a 4. Hopefully people can do that in their head fairly quickly. Most people do. So the magnitude of that, if I wrote it properly, Pythagoras, would be 2 squared plus 3 squared. And then this one, the magnitude of this one over here, by the way, it doesn't matter if they're negatives or positives. This, if they were negatives, it just means I'm flipping some of these around in a different direction, which when you square the negatives, they become positive anyway. So on this one here, it's a 3 and a 1, so it's a 3 squared and a 1 squared. Of course, a lot of people could do that in their head and just go, well, that's 4 and 9 is 13, and that's 9 and 1, which is 10. And of course, anyone not comfortable with using surds and multiplying surds, you're always allowed to multiply the insides. If they had numbers on the outside, you can multiply the outsides, and you can multiply the inside. So that's square root of 130. But I'm just going to look back on the basics of this. So if I had 2i, interesting on this case, I'm going to write it using the I and j form, because there's some concepts I want to get through to you about the I and j form. And then I've got 3i plus j. Get rid of this. Now, we're doing expanding of brackets just like we'd always expand brackets. And there's first, outside, inside, last, there's eyebrows. Or you can just, those who are confident, you can just write that as. Now, watch what I'm going to write. I'm going to be fairly fussy here. 2 3s are 6, and it's an I dot I. It's not at that point in time an I squared. So this one here would be the 2i by the j. So that's a 2i. Don't forget your underscoring of the vectors in Australia, especially in Western Australia. Have to underscore them, you may lose a mark. Next one I can go to 3 times the 3 is the 9, and I've got a j dot I. Probably doesn't matter if you write it the other way around. I shouldn't say probably, it doesn't matter. And then the last one is 3 times j times by another j. And we're talking about here the dot product. We're using dot products. Let's have a look what this means. This is where we're going to take our time and muck around for a minute. What does it mean by 6i? So really what we're going to do here is how can we get an I times an I? And I'm going to go here and then rub it off in a minute. Using the dot product formula, we're going to go the magnitude of I times by the magnitude of I and the cos of the angle in between. So we're back to dot product. Now dot product, we normally say A dot B. Magnitude of A, magnitude of B, cos of theta. So that's our basic rule for, or one of our basic rules for how to multiply two vectors. So if this is a 9, that's a 9. Now by definition, let's have a look what I times I is. It's the magnitude of I, which is 1. Just by definition, it's 1 unit in the x direction, in the positive x direction. And we're going to multiply that by another 1. And then what's the angle between any vector and itself? So a vector and itself, what's the angle in between them? And the angle between is 0. And this is a nice thing about using cos. Most of you should know that cos of 0 is 1, so we end up with 1. So I go back to this question up here, I've actually got 6 times 1. So using this idea, I end up with a 6 by 1. So what happens with the next one here? What's going to happen here? So this time I want an I times a j. I'm not worried about the 2 at the moment, just the I times the j. Now we're going to have the magnitude of I by the magnitude of j by the cos of the angle in between. Let's have a look at what that means. So the magnitude of I again is 1. By definition, the magnitude of j is a 1 unit in the vertical direction usually. And this time we've got the cos of I and a j. What's the angle between an I and a j? It's going to be 90 degrees. So again, this is what's interesting about using cos. So the cos of 90, most of you be aware, is 0. So we end up with 0. So this part becomes 2 times 0. Similarly, I'm going to go through just briefly through these. The j and the I will also become 0. So we've got 9 times 0. And just like we did with the I times the j times the j becomes 1. So this is 3 times 1. Let's have a look what's going on in the question. So we've ended up with a 6 times 1 plus a 3 times 1 there. We've ended up the same as 2 3s just there are just 6 and 3 1s there are just 3. So all we're looking at is the i's multiplying, because they will be continued as 6 lots of 1, and the j's multiplying because they'll be continued as 3 lots of 1. But all the other combinations, or the other 2 combinations, that times that becomes 0, and that times that becomes 0. So it just becomes a 6 plus 3. Now a lot of it can be shortcutted if you wanted to. A lot of people get the hang of it, and after a while, especially when we get to 3D, if that's 2, 3 and we're multiplying it by 3, 1, all you're going to do is 2 times 3 is 6 and 3 times 1 is 3, and you get your 9 there. So it gets pretty quick. Even if you've got 3 dimensions, works out pretty quick. Now, how are we going to get the angle between A and B? So we're back to the basic formula, our dot product formula. Let's have a look at what's going on here. How are we going to do it? So we know that A dot B, we can go back to the previous question here, you can work it out yourself by just going 2 3s are 6, 3 1s are 3, and you can just put a 9 there if you did it in your head, but we've got it written just there anyway. Now go back to here, I've got the magnitude of A by the magnitude of B. It might cause a bit of confusion, I put a dot there, because when we're talking about here, we have to have a dot, but here we don't, we write it normally as a multiplication. But if you wanted to write a dot, it means multiply. But a bit confusing in vectors because that dot has a very, very specific meaning, meaning that, or meaning that, which works out that way. Let's have a look. So the magnitude of A, we've already got that up here as root 13. Multiply the magnitude of B, we've already got that up here. So if you wanted to, you could just go 2 squared 4, 3 squared 9, so that's root 13. 3 squared 9, 1 squared 1, so that's root 10, cos theta. Now we can use that to get the answer. So we get cos theta is, if I divide this side by root 130, divide that side by root 130, go back to the basics. Now I've written down over here that 9 over root 130, in case you're putting in your calculator and you're not sure if you're getting it right, it's 789, I made that to 3 decimal places. It was pretty close to the 9 anyway. So then what's our angle? Put in your calculator, the inverse cos of that is 37.87 degrees. Now again, I rounded it off to 2 decimal places. A lot of times in maths, we won't worry about for angle 2 decimal places, probably worry about 1, if we even worry about 1. I think I would normally default to back to 1 decimal place just to make sure.